Alright, ladies and gentlemen, we're going to be learning 9.7 today. And 9.7 has to do with solving logs without common bases. So far what you guys have learned is we've dealt with common bases, being like if we did log base 5 of 25. Well, if you change 25 to be a base of 5, that would be a log base 5 of 5 squared. And the log and the 5 would cancel, and our answer was just 2. That's what we know so far. However, you might come to a little bit of a standstill when you have to solve something like this. Log base 5 of 7. Something like that. Okay. As of right now, it's impossible to solve because 7 is in a power of 5. They don't have common bases. However, we have this thing called the change of base formula, or the change of base theorem. Okay. It does exactly what it sounds like it's supposed to do. It changes our bases for us to work. Okay, and you guys are actually going to be allowed to use these things. So rejoice. Except don't have enough for everyone in here, so we might have to share amongst our groups. I conveniently put them on your tables for you guys before you came in because I'm that awesome. Well, I just think ahead, and honestly, I just don't trust Walker to get up and go get them for everyone. Sorry, Walker. I had to burn someone other than Nick this time. Okay, so change of base theorem. So for the change of base theorem, it says log base C of A. You can turn that to have both of them be log base 10, and this would be log of A divided by log of C. And all of the other formulas that we've done so far, like when we've condensed logs or we've expanded logs, we've only written it once, but when you're changing the base to go from a base of C to base 10, you have to make sure that you put the log in both of them. So, for example, that one that I put up there, log base 5 of 7. We're going to use this change of base formula and make this log of 7 divided by log of 5. Okay. The 7 is going to go on top. The base is going to go below. So what we're going to do from here is we're going to actually plug it into our calculator. So log of 7 is on top. So the log button is right here under the second. You're going to push log of 7. And it's always a good idea to close your parentheses. Some calculators it doesn't really matter, but it's always a good habit to close your parentheses. And log base 7 is 0.845. Okay, we're not going to write this down because what we're doing is we're taking log of 7 and we're going to divide it by log 5. So divide, see how it says answer? We're taking our answer from the previous problem and dividing it by log 5. So log 5 and we get 1.209. Okay. So for these problems, we're going to round to 3 decimal places to the nearest thousandth. So this is 1.209. That means 5 raised to the 1.209 power is almost equal to 7. It's not because we rounded to 3 decimal places, but look at how close it gets. Okay. So we're actually going to solve a few problems here. I want to make sure I get every situation. We get 7 to the x power equals 30. So we want to get x down out of the exponent. To get this out of the exponent, I'm going to take the log of both sides. So this is going to say log base 7 of 7 to the x power equals log base 7 of 30. I'm doing logs of both sides, and I'm picking a base 7 so I could cancel the 7 and get the x out of the exponent. So the logs and the bases will cancel, and I get x is equal to log base 7 of 30. So now that I have that change of base formula handy, I can rewrite these to both be base 10. So this is going to be log of 30 divided by log of 7. So in your instructions, I'm going to go back and read the instructions when we're done here. We got log of 30, so log of 30 in the calculator, and that's 1.477. I'm going to divide log of 30 by log of 7. Don't forget to close your parentheses. And we get a final answer of 1.747. Okay. You guys can follow along on your calculators if you want. But remember, we're going to round to the nearest thousandth. So that's 3 decimal places. So we actually have to look at the 4th decimal. That's an 8. So we need to round this up. So our final answer is 1.748. Okay. So in our instructions, it said solve for x. That's what we did right here. X is all by itself. So here's one way we could solve for x. So this would be like number 1 right here, the first part of our problem. It says in 2 different ways. So we're going to take this log and rewrite it using the change of base formula, that's the second way we can write the log. And the third part is to evaluate this using our scientific calculator. There's our final answer. Okay. This one is the one I'm really concerned about. Okay. So, next problem. We get 8 to the 2x power is equal to 74. Again, I want to get this 2x out of the exponent, so I need to drop the base of 8. I'm going to do that by taking the log of both sides. Log base 8 of 8 to the 2x is equal to log base 8 of 74. Again, I'm introducing the log to each side of the problem. Okay, so just gave you guys a little time off. Just kidding, I was actually texting wifey. It's 9:30 and I'm not home yet. She's afraid that I got off on the wrong bus stop. Again. Anyways, so log base 8 of 8, that would cancel, and I get 2x is equal to log base 8 of 74. So again, if I want to get x by itself, this is 2 times x. The opposite of times is divide. So I divide both sides by 2, and I'm not going to divide the 74 by 2. This right here is all one number. Okay, that's all one number. It's going to be like a 1 point something or a 2 point something. So we're going to divide this entire thing by 2. Which is actually the same thing as saying 1/2 times log base 8 of 74. You can always rewrite something being divided by 2 as times 1/2. It's the same thing. And we're going to use this change of base formula to make this 1/2 times log of 74 divided by log of 8. Okay. So we can do this a couple ways. We can either multiply by 0.5 first or do that later. So I'm going to do the logs first. I got log of 74 for 1.869. Divide it by the log in the denominator. Divide by log of 8. So that's 2.0698. But don't forget, I had to divide this expression by 2. That's what this 1/2 means. I have to either multiply this by 1/2 or divide it by 2. So divided by 2, my final answer is 1.035. final answer. Okay, a couple other examples. We got 3 more before we're done with this one. And we still have another lesson after this. So this other example is 5 times 2 to the 5x power equals 400. So, like all math problems, when we're solving for something, we're doing inverse operations to get this 5x or this x by itself. So, this right here is one expression. This isn't 5 times 2. This is 5 times 2 to the 5x power. Again, that's all one expression. So, let's get rid of that 5 first so we can start bringing that x out. Start off by dividing both sides by 5. 5 divided by 5 cancels. So this becomes 2 to the 5x power equals 400 divided by 5 is 80. So my first step, I just divided both sides by 5. My next step is I want to get rid of this 2 and get the 5x out of the exponent. So log base 2 of both sides. Let me write that underneath here. Log base 2 of 2 to the 5x equals log base 2 of 80. So again, I wanted to pull the 2 out of the off the base. I wanted to pull the base out and just get the exponent left. So to get rid of the base, I do logs. So log base 2 of 2. That's going to bring the 5x down out of the exponent. So 5x is equal to log base 2 of 80. Okay. I want to get x by itself still. So I need to divide both sides by 5. And dividing by 5 is the same thing as saying 1/5 times log base 2 of 80 for my answer. So this is going to be 1/5 times, using the change of base formula, this is going to be log of 80 divided by log 2. So it's calculator time. I got log of 80. Don't forget to end parentheses. 1.903 divided by log of 2. 6.321. And since I have this 1/5 in front, I got to remember to divide by 5. So divided by 5, gives me 1.264. Okay. Two more before we're done with this part. Another example. 7 to the x plus 2 equals 32. Okay, so get this down. So to get 7, I just looked up like I expected to see you guys. That was really trippy. Anyways, I need to get x plus 2 out of the exponent, which means I have to drop this base of 7. So log base 7 on both sides. And what that does for me is it allows me to drop this base. So x plus 2 comes down, and on the right side I have log base 7 of 32. So the exponent comes down. This is now log base 7 of 32. I still want x by itself, so I'm going to subtract 2 from both sides. And remember, I can't subtract 2 from 32. This isn't just a regular number. Log base 7 of 32 is all one thing. So I'm going to do the change of base formula for log base 7 of 32. This becomes log of 32 divided by the log of 7 minus 2. So to get x by itself, I subtracted 2 from both sides, and I changed this using the change of base formula. Remember, you don't subtract 32 and 2. It doesn't work like that, because this is its own number. So finally, we're going to plug it in. Log of 32 that gives us a number, divided by log of 7, that gives us another number, and then subtract 2 to end up with negative 0.219. There we go. One last problem before you get a little bit of time to work on your stuff. What happens if we end up with an E. Oh, spooky. So 3 times e to the x minus 4 equals 21. So remember, e to the x minus 4 is all one thing. So I need to get e by itself before I can move forward and take a log. That means I need to get rid of this 3 times stuff. So divide both sides by 3 to get e to the x minus 4 equals 21 divided by 3 is 7. So all we're doing is getting whatever has the variable in it by itself. So this is an e. We get rid of e with log natural. So ln of e to the x minus 4 equals ln of 7. Now, you could write base e if you want to. You don't have to. But if it makes you feel better, you could write this as a base e under here. Ln and e are inverses, so I'm left with x minus 4 equals ln of 7. Change this so they don't look like ones. And I still want to get x all by itself. So the opposite of minus 4 is plus 4. I add 4 to both sides. I get x equals the ln of 7 plus 4. Remember, ln of 7 is a number. You can't do 7 plus 4. This isn't 11. It doesn't work like that. So we're going to plug it into our calculators. The ln button is right underneath the log button. So it's ln of 7 plus 4. For 5.946. Final answer. Okay, take the next 15-20 minutes to work on some problems. I'm going to leave an answer key, but it's just the answers and no work at all, so that way you guys can check your work. If you do not show work on your homework, you do not get any credit. So make sure you guys are showing work. Good luck.